We're discussing the law of cosines in class, and you've already been introduced to this concept, but let me just remind you what we're dealing with here and when we'll be using the law of cosines. First of all, remember that we're dealing with a triangle labeled ABC. The angles are labeled with capital letters. The opposite sides are labeled with lowercase letters. And in particular, the law of cosines applies or is useful in two situations. When you're given information for two of the sides and the included angle, like I've outlined here where we have side C and side A and angle B, the only way you'll be able to solve for the other missing information is with the law of cosines. The law of sines will not help us because even if we were going to do sine B over B, we don't know letter B, we don't know any of the other angles or the sides. So you wouldn't even be able to set up the proportions for law of sine to make it work. The other situation where we'll be using the law of cosines is if all you know are the three measurements of the sides. So let's say we have this same triangle. I'm just slowly writing this in here. Remember that if all you know are the three sides, there's no way to use law of sines because you'll have two variables in the proportion for the angles. So for either of these situations, when you know two sides and the included angle, or when you know all three sides, then you want to use the law of cosines. And, you know, there are three forms of law of cosines because the letters might be switched up, but the law is really the same. It's essentially something like the Pythagorean theorem with this extra minus 2bc cosine A on the end. All right, let me show you a couple of the homework problems. I'll do them for you for free, and then you can get going with your assignment. So I'm going to start by working on number 11 here. We're given B is 7, C is 10, and A is angle 51. Now, I am going to draw the picture here just to convince you that this is the right situation. So let's draw A, B, C, and then A, B, and C, and we'll fill in the information that we know. I know angle A is 51 degrees. I know side B is 7. And I know side C is 10. So this is a perfect situation for the law of cosines. I have two sides and the angle between them. And so this becomes a fill-in-the-blank situation. We're asked to solve the triangle, so I want to find, here's what I'm looking for, angle B, angle C, and side A. All right. And so I'm going to start by trying to find side A. Okay. So to find side A, I'll fill in my answers up here on the top, but let's just write this out. I know that A squared is going to equal B squared, which would be 49, plus C squared, which would be 100, minus 2 times 7 times 10, 2 times B times C, times the cosine of 51 degrees. All I did is fill in the blanks on this top formula because I knew I was looking for letter A. A squared, that's not 9 squared, that's A squared, equals 49 plus 100 minus 2 times 7 times 10 times cosine 51. I'm going to type that in on my calculator, and I'll know what A squared is, and then I can finish off with the square root, I can get side A. And I typed in this expression here on my calculator, and I got A squared equals, we'll call it 60.9. And then to find out what A is, I just take the square root of 60.9. And that's going to end up being, of course, I got to find my square root button here. Here it is. Approximately 7.8. So letter A is 7.8. Now we have some options for finding the next angle, because once I know A is 7.8, I could do the law of sines. Since this video is about the law of cosines, though, I'm going to show you that you can also solve for an angle using the law of cosines. There's a little extra algebra here, but we'll go ahead and do that. So I know that A squared is 60.9. And so what I'm going to do is I'm going to solve for angle B here. And to get angle B, I'm going to use the second equation, which is b squared equals a squared plus c squared minus 2ac cosine b. So let me just draw a little line here so you can see that I'm starting a new calculation. Okay, so b squared, we've already done that, that's 49, equals a squared, which is 60.9, plus c squared, which is 100, minus 2 times 7.8, which is A, times 10, which is C, times the cosine of angle B. I got that off this middle. I circled over that, and now it's not letting me erase, but I'm doing the second equation here, the one that starts with b squared. And I've filled in all the information. I've got 49, which is b squared, 60.9, and so on. And notice that I'm trying to solve for angle B down here. So I'm going to go through a bunch of inverse operations here. Basically, I need to subtract 160.9 from 49 to start with. So when I do that, I get negative 111.9 equals, and then this math right here is negative 156. Please don't lose that minus sign. Negative 156 cosine B. We are trying to solve for B, so I'm going to solve for cosine B here. And what I'm going to do is divide negative 111.9. See if I can do that right on this calculator. Divided by negative 156. And I get positive 0.7173. And we use inverse cosine to figure out what the angle is, right? So I'm going to do inverse cosine on 0.7173. And when I do that, I get angle B to be, I got to type that in on here real quick, 44.2 degrees approximately. And so I've filled in the second of the missing pieces. Right? I found A to be 7.8 and B to be 44.2 degrees. You could have used the law of sines here to also get angle B. I used the law of cosine just to show you how we practice doing this. But I still have to find angle C. I'm just going to use subtraction for that one. So to get angle C, we're going to do 180 minus 44.2 minus the 51 that we were originally given. And so that angle is simply going to be, that's 84.8 degrees. And now we have all of the missing information. We have solved the triangle. The triangle has three angles, 44.2 degrees, 84.8 degrees, and then the given 51 degrees. And it has three sides. Side C is 10, side B is 7, and side A is 7.8. I'm going to do one more problem, number 12, on the next slide, and then I'll leave the rest for you to finish. In problem number 12, again, we're trying to solve the triangle. And again, I'm going to start with a picture and see if the law of cosine does apply here. Remember, we're doing capital A for the angle A, capital B, and capital C for the angles. And then side A, we're given as 5. Side B, we're given as 6. And side C, we're given as 7. So this is a perfect candidate for the law of cosines because we are given all three sides. We don't know any of the angles. The law of sines will not help us at this point. Okay, so we just have to decide which angle we want to go for first. Our goal is to solve the triangle, so just to keep in mind what our goal is, we need to find the measure of angle A, the measure of angle B, and the measure of angle C. We're trying to find the rest of the missing pieces. And I'm going to go for angle A first. So I'm going to use this top formula, and I'll just start writing out what I know. The formula is a squared plus b squared plus c squared, a squared equals b squared plus c squared minus 2bc cosine A. So for a squared, I'm going to put 25 because that's a squared, equals b squared is going to be 36, c squared is going to be 49, and then I have minus 2 times b times c, so that's times 6 times 7, and then cosine angle A is here on the end. And we're trying to find angle A, so we're going to have to solve for cosine A first. So I'll start by subtracting, well, what is 36 plus 49? 36 plus 49 is 85. So I'll start by subtracting 85 from 25, which we know is negative 60. So this is negative 60 equals, and then 2 times 6 times 7 is like 84. That's a negative 84. Please do not forget this negative sign right here. This number here is negative 84. And then, of course, I have the cosine A on the end here. That means I'm going to divide both sides by negative 84. Negative 60 divided by negative 84. And I get 0.7143 when I round it. Oops, that's supposed to be a 3 when I round it off. Okay, and then you know we're going to do inverse cosine. I'm not even going to write that in. I'm just going to hit the button on the calculator to get angle A. Angle A then becomes inverse cosine of that decimal answer is about 44.4 degrees. Angle A is 44.4. Okay, we use the law of cosine to get angle A. Just as a little review, I'm going to use the law of sines to get angle B, and then I'll use subtraction to get angle C. So for angle B, I'm going to put sine of B over 6 equals, and I'm going to put sine of A, which is 44.4, over 5. And to solve this, we multiply both sides by 6, remember. And I'll do the inverse sine on this equation here. I'm going to do it all at once. I'm going to figure out the decimal number, and I'll do the inverse sine on that. So the sine of 44.4 divided by 5 times 6. That gives me a decimal, and I'm going to do the inverse sine on that decimal right on my calculator, and I get about 57.1 degrees. So angle B turns out to be 57.1 using the law of sines, and that is the right answer. Remember, I did a bunch of calculations on my calculator to get that. And so I'm going to fill that in here, 57.1. And then to finish this off, let's just subtract from 180. There's no reason to run through all that again. So 180 minus 44.4 minus 57.1, and that's going to equal 78.5 degrees. So for this triangle, we know that we were given the three sides of 7, 5, and 6. And now we know that the three angles are 44 degrees, 44.4, 57.1, and 78.5. In this example, we started by using the law of cosine to get, to get one of the angles. Now I'm just tapping buttons on this thing. We started using the law of cosines, but then I shifted to the law of sines to get the second angle. And of course, we use subtraction to get the third angle. So your job is going to be to, of course, copy my number 11 and number 12, but then finish 13 through 16. Good luck, and let me know if you have any questions. Take care.